Yo, what's up YouTube? Kiwi the Cat here, and today we're looking at everything to do with linear equations, from a basic overview, to graphing, to all types of questions you'll see involving these functions. Let's get right into the video. So when we talk about linear equations, there's 5 things that we gotta know. And I suggest memorizing these 5 things for the SAT, because in one question or another, more than likely you'll be tested on all these things. So number 1 is the slope. The slope is equal to rise over run, and it's equal to y2 minus y1 over x2 minus x1. So let me break this down. Your slope is basically your rate of change of this line. What I mean by rise over run, I mean by if I pick 2 points on the line, let's say I pick here and here. If I go ahead and find the increase in y, or the rise, and I go ahead and find this run, or the increase in x, I can go ahead and find the slope. You can think of slope of how steep the line is. This would be a lower slope, and this would be a higher slope. Number 2 is the y-intercept. The y-intercept is what value y is when x is 0. So you can see here, the y-intercept in this case would be 1. The line crosses the y-axis at 1 when x is equal to 0. This is very helpful in case the question is asking when this value is 0, or when whatever this value would be is 0, what is this value? You can go ahead and find the answer for that. Number 3 is the basic equation for a line. And this is called slope-intercept form, where m is your slope, which we found up here, y is any y value, x is your x value, and b is your y-intercept. And let's say you want to find b, and you have y, x, and m, you can use it to find b. Number 4, this is another equation for a line. This is point-slope form. So if you have 2 points, let's say I pick a point here, and I use this same point here, and I pick these 2 points, and I go ahead and find the slope using slope form, and put this entire equation into this equation. This is very helpful in case you want to go ahead and find the y-intercept, and the equation only, or the question only gives you 2 points. You can go ahead and just use this equation and not have to draw anything out. And number 5, the x-intercept is when y is equal to 0. So this is the same thing as the y-intercept, except y is equal to 0. So in this case, when y is 0, x is about -1/2. So if the question is asking, when this value is 0, whatever this axis is labeled, what is this value? You can go ahead, find 0 for y, and look where this graph crosses x. Or, better yet, you can go ahead and use one of these 2 equations, plug in 0 for y, plug in the rest of your variables, and solve for x. If any of these things still confuse you, don't worry. Next, we're going to go over some practice problems to explain all the concepts I just talked about, and also I'm going to show you step by step how to answer any question about linear equations. Okay, now let's do some practice problems. So here we have a linear equation. For the graph, identify the slope, the x-intercept, and the y-intercept. Feel free to pause and try and figure it out. So first we want to go ahead and find the slope. So we know the slope is the rise over run. So we go ahead, we find our x value, right? We just pick any x value. We pick any y value. We find the rise. For this particular point, we have a rise of 6. We find the run, which would be of 2. And we do rise over run, which is 6 over 2. We get 3. Next, we're asked to find the x-intercept. So to find an x-intercept, that's when our y value is 0, as we can see here. And we look for when the graph crosses the x-axis, which is right here. So our x-intercept would be -2. Next, we need to go ahead and find our y-intercept. That's when x is equal to 0. So we go ahead and look where x is equal to 0, and we look where that y graph crosses the y-axis. We get 6. So our y-intercept is 6. And lastly, our equation would be y is equal to 3x, 3 our slope, plus 6 our y-intercept. And this is slope-intercept form. Okay, so more practice problems. So this question asks us, find the slope y-intercept and the x-intercept for the graph with points 2, 2 and 6, 10. Now, usually, a lot of kids would get confused because with just this information, we can't use slope-intercept form, and we can't use rise over run because we're not given a graph. So they forget the two most important equations and two equations I request that you guys memorize if you take the SAT or for any algebra-based class. And that's the slope and point slope form equations. These equations allow us to go ahead and find the slope and find the actual equation for a line with just points. So we go ahead and find our slope. This is y2 minus y1 over x2 minus x1. When I go ahead and label my points and pick which is y1 and y2, I want my bigger points to be the 2's and my smaller points to be the 1's so that my slope is not negative. So in this case, I'll make 10y2 and 6x2 and 2y1 and the other 2x1. And plugging this in, we have 10 minus 2 over 6 minus 2, which gives us 8 over 4, which gives us 2 as our slope. Now that we have our slope, we can go ahead and plug in our slope and one of these set of coordinates into our point slope form equation and get the equation of this line. I'm going to do 2 over 2. You guys can go ahead and do 6 over 10 and you'll find that we'll get the same answer. So if we go ahead and plug that in, we have our y minus our y value, which is 2, is equal to our slope 2, x minus our x value 2. We have y minus 2, and if we distribute this 2 to both of these numbers, we have 2x minus 4. And if we add 2 to both sides, we have y is equal to 2x minus 2. And this is our equation. As you can see here, we got the right answer. Next, we're asked for the x-intercept. Now what's great is, now that we have this equation, we can just go ahead and plug in 0 for our y and find the x-intercept, because our x-intercept is when y is equal to 0. So we do this, we have 0 is equal to 2x minus 2. And if we solve for x, we can add 2 on both sides. And we get 2 is equal to 2x. And if we divide by 2 on both sides, we get x is equal to 1. So our x-intercept, or when y is 0, would be 1, 0. And if we look, that's our right answer. And lastly, they ask for our y-intercept. And just like the x-intercept, our y-intercept is when x is equal to 0. So we literally can take this same equation and have y is equal to 2 times 0 minus 2. This is y is equal to 0 minus 2, or y is equal to negative 2. So our y-intercept would be 0, negative 2. And if we go ahead and check, we get the right answer. If we go ahead and I pulled up a graph of this line, we can also go ahead and check our answers. So if we go ahead and pick 2 points, negative 2, for example, and 1/2, we can go ahead and see that this crosses our y, and our x is 0, and negative 2 is our y-intercept, as seen here. And also, our x-intercept is about 1, which is also here. This is also when our y value is 0. If we wanted to go ahead and find the slope, we can pick another 2 points. I'm going to pick this point and this point up here. We can do our rise, our run, as you see, from 0 to 2, that's a rise of 2. And from 1 to 2, that's a run of 1. 2 over 1 is 2. As you can see, that's our slope. And as you can see in our equation, 2 would represent our slope, so we got that right as well. Okay, next set of practice problems. I want you guys to go ahead and using this graph, answer the following 3 questions. You can go ahead and pause now and then check your answers later. Okay, first question. How many miles is Josh from his home after 0 hours? So the first thing I want to go ahead and do is look at our graph. So we have Josh's car trip, and on the y-axis we have number of miles from Josh's home, and on the x-axis we have hours. The question is asking us how many miles is Josh from his home after 0 hours. So we look on our axis and we look for hours. When x is 0, right, we're looking for our y, the number of miles. So when x is 0, number of miles is 160. So that would be our answer. As you can see, we got it right. Next question. How many miles does Josh travel during his car trip every hour? So now this is asking for a rate of change. The way I identified that it's asking for a rate of change is because the question is asking us when miles increases or decreases, what happens to time, right? Or when time increases or decreases, what happens to miles, right? So since I'm looking for what happens to miles during time, each hour, I can look for an increase in hours and then see what happens to my miles. We can do this by using the slope. So if I go ahead and see after 1 hour, we decrease 40 miles. So if I go ahead and use my slope equation, we'll have rise over run. If we have a decrease, right, in your y-axis, that means your rise is going to be negative. So since we decrease by 40, our rise is going to be negative 40. Since our run is still increasing, that's still going to be positive. A decreasing run would mean the arrow is going the opposite way. So this would be 1. This gives us a rise over run of negative 40. So how many miles does Josh travel during his car trip every hour? He travels negative 40 miles every hour. As you can see, we got that right as well. Last question. How long does it take for Josh to get home? So if we're looking for how long it takes Josh to get home, we know the miles has to be 0 because this is number of miles from Josh's home. When Josh is 0 miles from his home, he's already at home. So since y-axis has to be 0, since the number of miles has to be 0, we look for the x-axis. And this is kind of like looking for the x-intercept, which I talked about before. So when y is 0, right, we look across, it crosses x at 4. So it takes him 4 hours to get home. As you can see, we got the right answer as well. Feel free to pause or rewind if you want to go ahead and see how I worked it out again. Alright guys, that's the end of the video. If this helped you understand linear equations better, please leave a like. Also, if you're confused at anything I went over, leave a question in the comments. I'll do my best to answer all of them. Enjoy the rest of your day, guys.